Hello dear students, let us start a new chapter of Standard 10th Physics ICSE syllabus, that is chapter 6 Spectrum. I am going to divide this chapter into two parts. Okay, so let us start part 1. In this video, our objective will be to learn deviation in a triangular prism, dependence of deviation on the color, dispersion, spectrum and electromagnetic spectrum. So let us start today's session with the topic deviation of triangular prism. What do you mean by deviation? Deviation is related to the refraction of light. Refraction of light. Now what do you mean by refraction of light? Refraction is nothing but bending of light, right? Bending of light. But why light bends? Light bends, you know very well that refraction takes place in two mediums, right? Two mediums. So light bends because of the variation in the density of both the mediums. Variation of density of both the mediums, right? So if the density varies, then definitely the speed of the light will also vary. Okay, that's why the light bends when it passes from one medium to another medium. Now let us understand this topic more with the help of this diagram. Okay, this is a triangular prism ABC. AB and AC are the two refracting surfaces. Okay, two refracting surfaces. Now let us consider a white light incident on the surface AB. This is the white light incident on the surface. Now what will happen? So this is your air, this is your glass. So what will happen, children? Definitely there is a variation in the density. So the light will bend. It will bend. Okay, it will bend like this. Okay, so this is the direction. Don't forget to put the arrow mark. Arrow mark shows you the direction of the light. Again, when the light strike to the refracting surface AC, what will happen, children? Again you will see that this is glass and this is air. So variation in the density. And what will happen? The light will bend like this. So this is the arrow mark. So this is your incident ray, this is your refracted ray, and this is your emergent ray. Okay, let us produce the incident ray. I am producing this incident ray because you know very well the property of light. Light always travel in a straight line. Okay, so let us produce this emergent ray also. This is your emergent ray. So we are producing this emergent ray also. So, and here let us draw the normal. Let us draw the normal. So this is your angle of incidence. Okay, this is your angle of incidence. So now tell me where we will get the deviation in case of first refracting surface. So light should travel like this, but it bends because of the variation in the density. So this is your deviation 1. Okay, so now here also you see light is bending like this. So where we will get the deviation 2? Here is the deviation 2. Here is the deviation 2. Now tell me where we will get the total deviation. Total deviation we will get where the incident ray and emergent ray when produced it meets. Okay, here is getting, yes, when it is produced, both the incident ray and emergent ray, when it is produced, here they are meeting. So this will be your total deviation. This will be your total deviation. Okay, so this is angle of incidence, this is deviation 1 for this surface, this is deviation 2 for this surface, and total deviation when you are producing the incident and emergent ray you are getting here. So total deviation is nothing but delta is equal to delta 1 plus delta 2. Delta 1 is nothing but deviation at the surface AB, and delta 2 is nothing but deviation at the surface AC. Okay, so now let us learn about the factors on which this angle of deviation depends. First one is angle of incidence, that is I, of course. Okay, angle of incident. Then second one is nothing but the angle of the prism. This is considered as the angle of prism, that is A. Okay, and third one, the refractive index. The refractive index. Okay, now tell me, children, what do you mean by refractive index? Okay. The refractive index is nothing but the measuring the bending of light when a ray of light is passing from one medium to another medium. Okay, it is also denoted by the symbol mu, and it can be also defined as mu is equal to the ratio of speed of light in air to the speed of light in any medium. So this c is the speed of light in air and v is the speed of light in medium. So these are the three factors on which the angle of deviation depends. What are they? The angle of incidence, the angle of prism and the refractive index. But refractive index depends on wavelength, that is color. So if you remember, which one is the subjective nature and which one is the objective nature out of this color and wavelength? Color is the subjective nature because it will vary from person to person based on the visibility of the person, okay? But wavelength, it will remain fixed, the value will remain fixed. So this is the objective nature and this is the subjective nature. So since refractive index depends on wavelength and refractive index is a factor of angle of deviation, so angle of deviation also depends upon the color and the wavelength, okay? It also depends upon the factor called color and the wavelength, or we can say that color, because wavelength is the objective nature of the color, okay? This is nothing but the concept of the deviation of triangular prism. Our next topic is dispersion of white light. This is your triangular glass prism. Yes, this is your white light. Now what, and this AB and AC are two refracting surfaces of this glass prism. Now what happened, children? When this white light is getting struck on this refracting surface AB, you can see that you can see very clearly 7 colors, right? So this white light is getting splitted into 7 colors. This phenomenon is known as dispersion. So we can say that on this surface AB, dispersion took place. So what do you mean by dispersion? The phenomenon of splitting of white light by a prism into its constituent color is known as dispersion. Okay, here the white light is getting splitted into 7 colors. Okay, now what happened? Again they are moving and they are passing through the refracting surface AC. Now what happens on this refracting surface AC? On this surface, what happens? Normal refraction took place. Yes, refraction took place, that is bending of light took place. Now what do you mean by spectrum? Spectrum is nothing but when white light is passed through a prism, this is white light and it's passing through the prism, the band of colors are seen on a screen. These all are the band of colors. Okay, when we are seeing this band of colors, when this white light is getting splitted into 7 colors, okay, then we are seeing the band of 7 color, that is spectrum. So when white light is passed through a prism, the band of colors are seen on a screen and band of those 7 colors are known as spectrum. So this is a band of 7 color, that is Vigyor, VIBGYOR, and this is known as spectrum. V is of least wavelength, that is 4000 Armstrong, and R is of highest wavelength, that is 8000 Armstrong. So we can also express this wavelength in terms of nanometer and meter. So the relation is like that: 1 nanometer is equal to 10 to the power minus 9 meter is equal to 10 Armstrong. 10 Armstrong, okay. Wavelength can also expressed in terms of nanometer and meter. Okay, here you can see very clearly the wavelength is expressed in Armstrong. So Armstrong is also one unit of wavelength. Okay, so this is all about dispersion and spectrum. Now let us compare between these two, the wavelength, the speed, the refractive index and deviation between these two light, that is your violet and red. Okay, between these two colors. Okay, now see, in case of red, when a ray of light is passing through the prism, what can you see? It is getting it's splitting into 7 colors. Okay, so here you can see the red light and here you can see the violet light. And if I will ask you which one deviates more, you can say very clearly that violet deviates more and red color deviates least. So violet deviates more and red color deviates least. Now what about the speed? The speed of red light will be more and the speed of violet light will be less. Okay, less bending, then more speed. More bending, then less speed. Okay, now what about the wavelength? You know very well that wavelength is directly related to the speed. Okay, wavelength is directly related to the speed. So here wavelength is more, so speed of red light will be more. Here in case of violet, the wavelength will be less. Now what about the refractive index? Okay, what about the refractive index? We know that refractive index and wavelength are inversely proportional to each other. Refractive index and wavelength are inversely proportional to each other. So in case of red light, since the wavelength is more, so the refractive index will be less. In case of violet light, the wavelength is less, so refractive index will be more. Okay, so like this you can differentiate these two color, red and violet. Children, try to learn this order of the spectrum, okay, and also try to learn how can you differentiate this. Mainly question comes about this red and violet light. Okay, so try to learn the difference, because it may be asked that which out of this red and violet, which color is deviating more, which color is having more refractive index. Okay, so just go through this. Electromagnetic spectrum. What do you mean by electromagnetic spectrum? Electromagnetic spectrum shows the range of wavelength and frequencies of electromagnetic radiations. Okay, so what do you mean by electromagnetic spectrum? Electromagnetic spectrum is a spectrum which shows the range of wavelength and frequencies of electromagnetic radiation. But what do you mean by electromagnetic radiation? Electromagnetic radiation is nothing but the vibration produced, because you know very well that in electromagnetic we are having electric and magnetic field, as I told you earlier. So electromagnetic radiation can be defined as the vibration produced, of course in the form of wave, okay, in the form of wave, when electric field is coming in contact with magnetic field, and here electric field is perpendicular to magnetic field. Okay, so what do you mean by electromagnetic radiation? Electromagnetic radiation is nothing but the vibration produced in the form of wave when electric field is coming in contact with magnetic field, and of course they are electric field and magnetic field are perpendicular to each other. So here you can see very clearly the electromagnetic spectrum. Okay, electromagnetic spectrum. So this is your visible range. This is your visible spectrum. In visible spectrum we are getting Vibgyor. In visible spectrum, this is your visible spectrum. In visible spectrum we are getting Vibgyor. Okay, so if we move beyond the red extreme, this is your violet and this is your red. So if you are moving beyond the red extreme, you can see the rays like infrared, microwaves and radio waves. If you are moving beyond the violet extreme, you can see ultraviolet, X-rays and gamma rays. So what is the wavelength of red? As I told you, it's 8000 Armstrong. It is 8000 Armstrong. So it is very clear that as you are moving beyond the red extreme, what happens to the wavelength? The wavelength will increase. Okay, the wavelength will increase. That's why it is shown here as in this arrow mark. This is the arrow mark which shows that as you are moving from gamma rays to radio rays, what happens to the wavelength? Wavelength increases. But what happens to the frequency? You know that we are having the formula V is equal to F lambda, or F is equal to V by lambda. So how this frequency and lambda are related to each other? Inversely. So here wavelength increases, but what happens to the frequency? Decreases. Decreasing frequency. Okay, decreasing frequency. Here wavelength increases but frequency decreases. So this is your arrow mark. Okay, this frequency decreases. So here this is the electromagnetic spectrum. just go through all the rays, that is gamma rays, x-rays, ultraviolet, infrared, microwaves and radio waves. Children, sometimes question is asked that arrange all these rays in increasing order of wavelength or decreasing order of frequency. Okay, so you need to remember this pattern or sequence, then only you will be able to answer such question.